everyone. All right, we have been learning about rational numbers, comparing them, ordering them, putting them from least to greatest, graphing them and their opposites on a number line. You've also added and subtracted integers. And so what we're going to do today is we are going to look back at adding and subtracting integers and think about how we use the chips to apply some new rules for rational numbers. So we're going to do the same thing with integers when we added with our chips to apply that to rational numbers. Okay, we know that rational numbers are numbers that are either fractions or decimals. And so let's go ahead and look at some examples so that you can see what exactly I mean. So we have example A, and example A says that I have negative 8/3 plus 5/6. Okay, so let's think about fractions. When we have fractions, you cannot add fractions unless they have the same denominator. So we need to make our fractions first have the same denominator. Once they have the same denominator, then you can add their numerators. So 3 and 6, we can use this 3 and get it to 6 so that they both have a common denominator that's out of 6. So we're going to take negative 8/3 and we're going to multiply it by 2/2. The reason why is because to get from 3 to 6, we have to multiply by 2. And what you do to the top, what you do to the bottom, you need to do to the top. So 3 times 2 is 6, and 8 times 2 is 16, and then we're going to pull the negative sign over with it. So now you have 16/6 plus 5/6. So this right here is the new problem that we are going to solve. Negative 16/6 plus 5/6. All right, so how do you add this with a negative? In normal addition of fractions, you would just add the tops now and move the bottom number over. Okay, so everything would be out of 6. It's the same thing even though there's a negative. We're going to ignore the bottom now because we don't need to worry about adding on the bottom. And we're just going to focus on the top. So on the top, I have, let me get my red, I have negative 16. So this is like saying I have 16 reds, and I add on 5 positives. Sorry, there's a school bus stop right outside my window, and the bus was really loud today. Okay, so what I was saying was that we have negative 16 and we add 5 positives. So if I had negative 16 and I add 5 positives, I would have negative 11. So when I add my two rational numbers together, I get a negative 11/16. So negative 11/16. As a 6th grader, you could, we are going to try to move you towards reducing this into a mixed number now. So we're going to say I have negative 11, or I have 11 divided by 6, which means that I can make one group, one whole, with 5/6 left over. So 5/6 left over. So my answer is 1 and 5/6. We want to try to get it to a whole and a fraction. All right, let's go ahead and do another example. I want to do another example with a fraction. Where are my extra examples? Great, extra example. All right, so in this example, I have example B. I have 4/5, and I'm going to add that to a -3/10. Okay, so again, we're looking at this the exact same as integers, except we're adding rational numbers. So the first thing that we need to do is I have a fraction plus a fraction. So a fraction plus a fraction means that I am going to make common denominators. So I know that 5 can become 10 if I multiply by 2. So 4/5, I'm going to multiply this by 2/2. And that gives me a denominator of 10 and a numerator of 8. So really, I'm adding 8/10 plus -3/10. Okay, so let's rewrite this and now solve. So I have 8/10 plus -3/10. And I am ready to solve. So let's go ahead and solve this thing. Common denominators, I have 8 positives. And then I add on 3 negatives. So if I had 8 positives, let's do this out here. There's my 8 positives, and I add on 3 negatives. These are going to go away. And I'm left with 5 positives. So I have 5/10. 5/10 can now be reduced. I can divide 5/10 in half or divide it by 2/2. And I get 1/2. So my answer is 1/2. So the only difference that you are adding into this process with this that's different from adding integers is that now you have a common denominator. Okay, so that's it. Now you have a common denominator. Once you get rid of your common denominator, you are good to go. Solve it like a normal integer. Okay, let's do some try-its with the fractions, and then we will look at decimals. Okay, so here are your try-its. Okay, so try-it number 1, I have -1/2 plus -3/2. Oh, on this one, they already gave you a common denominator. Lucky. All right, and then let's do this one and see if you remember how to make an improper fraction. So this one, you'll have to make an improper fraction first. So -1 3/8, and we did improper fractions when we were dividing fractions. Divide plus 3/4. Okay, go ahead and do this. Try it real quick. Hit play when you are ready to solve. All right, so since they have the same common denominators, we're just going to look at the tops. I have -1 plus a -3, and I know when I have reds and I add on more reds, I have a lot of reds. So I have -4/2. I can reduce this down from -4/2. I can reduce this down to -2. So my answer here is -2. If I had -1 or 1 red, and then I add on 3 more reds, I now have 4 reds. Okay, let's look at this one. This one I need to convert to an improper fraction first, and I can convert that to an improper fraction by remembering that 1 whole is like 8 out of 8. So 8 out of 8 plus 3 gives me 11 over 8, or I could go like this, 8 times 1 plus 3 and go around in a circle like this. So 8 times 1 is 8, plus 3 is 11, negative 11 over 8, plus I have 3/4. Okay, now I have an improper fraction. So my job now is to make common denominators. So now I want common denominators. I know that 4 can become 8. So 3/4 times 2 over 2, that gives me 8, and that gives me 6. Okay, so I am really adding negative 11 over 8 plus 6 over 8. So I have negative 11, and I add to negative 11, I add 6 positives, which means that, so if we want to show it, 6, 7, 8, 9, 10, 11, and I add on 6 positives, those all go away. All right, and I'm left with 5 negatives. So my answer is negative 5 over 8. Negative 5 over 8. All right, now, how did you do on those? Because we're going to turn the page now, and we are going to look at adding integers when they have a decimal. Okay, so when they have a decimal. All right, so let's go ahead and look at adding integers when they have a decimal. All right, example 2, because that, again, we're still adding rational numbers. So example A. Example A says to find the sum of negative 75 hundredths plus negative 1 5/10. Okay, so what are we going to do here? Well, the first thing that we're going to do is we are going to look at these like fractions. Okay, so we're just going to look at these like fractions. I have 0.75, or I have 75 hundredths. So I'm going to rewrite this as negative 75 hundredths. Okay, so it's in the tenths place, hundredths place, so 75 hundredths. And I'm going to add that to one whole and 5 tenths. 5 tenths, because this is in the tenths place. So now I have 2 fractions. But there's some work that I need to do in order to make it so that I can add these 2 things together. I cannot add this fraction to this fraction. 1, this is a whole number and a fraction. So I need to make an improper fraction. But 2, this is out of tenths, and this one's out of hundredths. So we're going to have to do some work here. So let's go ahead and convert this number here. Negative 1 5/10. We're going to multiply. 10 times 1 is 10, plus 5 is 15. So really I have negative 15 tenths. Again, I want it to 100ths. So I'm going to multiply by 10. So 10 over 10, and that gives me 100. And that gives me 150. All right, now we are ready to use our two numbers to solve. So I'm going to start with, let's use a different color. This one, I have negative 75 over 100, and I'm going to add to it negative 150 over 100. We're ignoring the bottoms. They are the exact same denominator, so we're going to ignore those. I have negative 75, and I add on 150 more. So I know that that is going to give me 150, 225. Let's add that like this. So 150 plus 75. It's 225. So I have a negative 225. I don't know why my brain was not working on that one. Okay, so our total is negative 225. That is a really big number on top. We can turn this improper fraction now into a proper fraction by dividing by 100. So this equals negative 2 and 25 hundredths, or negative 2 and 1/4. Okay, so you're taking what you learned in this last page right here with fractions, and you are converting it into a decimal into a fraction so that way you can subtract. I mean add. We're not subtracting until next lesson. Okay, let's do another example, and then I'm going to give you some try-its. All right, our next example, example B. Example B says, when I find it, where is extra example 2? Oh, this one's kind of a big number. Okay, here's another way that we can do this one. Negative 3 and 92 hundredths plus negative 6.89. Okay, here's another way that you can solve this problem. If you don't want to turn it into a fraction, you can always just line up the decimal points and add, because they both have the exact same sign. So because they're both a negative, you can add and know that you are getting more negatives. Okay, so this one is an easy one to line up because you're just going to have a bunch of reds no matter what you do. If you have a positive and a negative, the best way to think about that one is to convert it into fractions. So if I have negative 3.92, I'm going to add negative 6.89. And then we're just going to add. We're going to line them up and we're going to add. So 9, 10, 11, carry my 1. So that's 18, and I get 1 whole right there. So again, I still have all reds. That's all I have. So that's negative 10 reds. So I have negative 10 and 81 hundredths. So there's another way that you can think about this problem if you would like to. So you can convert it to fractions and work with fractions, or if you are able to see decimals in your head, you can work with decimals. All right, it is time for our try-its. Okay, and today's try-its for decimals, adding decimals, looks like this. So I have try-it number 1 for decimals. I have negative 5 3/5 plus 4. And then try-it number 2. I have 1 65 hundredths plus -9/10. All right, so go ahead and hit pause right now so you don't hear me solving, and then when you are ready, you can come on back to the Google Meet and start solving. All right. Okay, so let's go ahead and start with a fraction, -5 35/100ths. And I have +4/1. Because 4 wholes, I just put it over 1, and then I can go from there. Now we're going to multiply and add. So multiply here, and then add to make an improper fraction. So I have 535/100, and this is a negative. Plus, I have 400/100. And the reason why I did that is just because to get from 1 to 100, I would multiply by 100. And when I do the top, I need to do to the bottom. All right, now I have -535, and I add on some yellows. So these yellows are going to cancel out 400 of the negatives I have here. So really, I have -135/100, and I can reduce this down. Now I'll reduce this part down to -1/35, or 1.35. 1/35. Okay, and then our next one over here, that is what we didn't do up here. So let's check this out real quick. This 25/100ths, I forgot. We should have put it back as 0.25 or 25/100ths. Or 1/4. 1/4 is 25 cents. Sorry about that. Okay, so let's keep going here. On to this problem. So on this problem, I have 1/65. Plus, I have a -9/10. I can convert. We're going to multiply this one by 10/10 to get it to be 100. So that gives me 90/100. Okay, so now, and then over here, I'm going to add, or multiply, and then add. So 100 plus 65 is 165/100, plus a -90/100. All right, so I have 165 yellows, and I'm going to add on a -90. Okay, or I'm essentially removing 90 yellows. So when I remove 90 yellows, there's so many colors here. So when I remove those, I get 75/100ths. Or as a decimal, when I put this back in a decimal form, I get 75/100ths. So this one should have been -1, and there we go. I forgot my negative sign. I had it there and I didn't bring it over. So -1 3/5, this, or 35/100ths, and this one is 75/100ths. All right, how did you do on this? Go ahead and answer your essential question, and then put your rating or your level of understanding out to the side. How do we add rational numbers? Okay, thank you for all of your hard work and effort, and make it a great day.